right, everyone. I hope you know by now, but I suggested that you guys grab these packets from the library if you don't like writing everything down. And of course, we cannot do the Zoom code anymore due to predators, and I'm so sorry, but I hope you've been coming to my Monday, Wednesday, and Friday Zoom meetings from noon to 1, at 10 a.m. and 1 p.m. So although I'm not just doing 2 times, I'm trying to do 2 times a day for Monday, Wednesday, and Friday to help you guys out. So we already did the first module, and I already put in 3 videos for the binomial because I personally do not like how this is written at all. So I hope that you watched the video about Pascal's triangle. If you haven't, please stop what you're doing and go take care of that. But what I had said is to do the odds only on these. And then of course, I want to remind you that all the answers are in the back, okay? Which is great. So don't miss that. But what I want to talk about today is these normal distributions, right? So we have all of these curves. Okay, so I'm going to actually write on this so that we can talk about it. But what you need to know, there's a lot of different words here, but the mean, right? The mean means the average. And so like whenever an average is when I add up a total and I divide by however many that is, right? So we'll talk about that in a little bit, but that's pretty much what's going on. So this mean is this guy. He's going to be in the middle, and I could say a lot of things about that, but I'm on YouTube and so I don't feel like losing my job right now. But basically standard deviations are mean. Okay, so that's our average. Then notice this other, oh shoot, did that go through? It's okay. Then you guys can see, this is a weird way of writing it, but what it's saying is it's saying at 1 standard deviation. 1 standard deviation is 68% of the data. So what it's saying is from the mean, we can add or subtract 1 standard deviation. So this is 1 standard deviation. You can almost see where I was going with that. STDs are mean. Oh my gosh, I can't believe I just said that. I'm gonna lose my job. Anyways, you get what I'm saying. Okay. Right here, though, you can see it says mean minus 2 standard deviations and mean plus standard. So this distance is 2 standard deviations. Okay, so it's 95% of the data. So if we only go 1, we've asked a majority of students, right, 68, but 95, that's an 8. That's a big chunk. But if we're being really specific in in our data, we would go out 3 standard deviations because that's going to give me 99.7. And the reason why we say that is because there's a chance that 0.3%, right? We have a margin of error, which we'll talk about another time. But there's a chance that there's something outside the data, right? There's always someone that's super smart or super stupid, right? Or super expensive or super cheap in this realm. Okay. Now this is the money right here. Okay. Because what they're saying is that data is each one. Let me see if we can. Okay, so then they talk about it some more. I don't like how they wrote that, so I'm gonna skip that. And then thank the Lord that I got them to take off Z-scores. Oh, if you got an accountant for a parent, just give them a high five and say, Miss Cooper, my math teacher, thinks you're amazing. We are not gonna do Z-scores, okay? Now this is other information you need to know. Bell, the bell is the normal. That's when the mean equals the median, okay? And then right here at skew left, the way I would teach you guys is if I was on the top of this mountain, would I want to ski to the right to my death or ski to the left? Nice and easy. We would ski left. I know some of you guys are like, no, I want to go off the cliff. Please don't. Go down left, ski left. Right here, ski right. Okay, that's the best drawing I have here. So it's like which one of these would be normal. So a bell shape is called normal. Why? We don't know. That's just what it is. Okay, kids. So that's which one of those is more normal. We would say this one. This one's more of a skew right, and this one's more of a skew left. Okay, so then the homework looks something like this. I'm not going to do all of it, but it's saying, looking at this, give the percentage of the area underneath the curve. So you kind of have to flip back and forth. So right here, remember we had this data. I'm going to have to be fancy here. Okay. Ooh, showing it both at one time, but now how will I write? Okay, we're going to have to, okay, I'm going to have to move my computer. I'm so sorry. You guys that have been my students, though, you're like, this is par for the course. Okay, here we go. So here's the data, and you can see these are shaded. So my personal opinion is I would say, okay, this one's 34, and this one is 13.5, and this one is 2.35, and it looks to me like this one is also 0.15. Looks like that all is, oh my gosh. Let me move the papers. Okay. So when if I were to add that up, and some of you guys are very smart and you already know what the answer is, but it's okay, we're gonna do it anyways for everyone who doesn't know. All you people in the back not paying attention. Oh, no, 1, 5. Look at that, 50%. You should not be shocked. That's half, yeah? Yeah, okay. So, but look at this one. It says mu plus 2. So right here, that means that 34 is not there, the 13.5 is not there, it's just the 2.35, so it's just, just 2.235, and the 0.15, which of course is 2.5, right? Because it's just these two. What gets tough is when it's like this. Right? That's so many weird things that's happening there. So what it says is a normal distribution has a mean and standard deviation of what did they call that? Sigma. Find where x is less than u minus sigma. So this one over here says 2 sigmas. This is just 1. So where is it less than? Well, looking over here, here is my, get focused. Right here, here's my x, so what's less than, this is less than, this is lower, this is greater, right? So I would add all of these. So I would say 0.15 plus 2.35 plus 13.5 like this. And you can say that would be equal to 16 because you're saying everything that's left of that. So what I do is I find that symbol, and less than means this way. So I added these 3 terms together to get me the 16. Now this one is very interesting. It says find between x minus 1 and x plus 1. Well, we already have that right here. X minus 1 to x plus 1 is 68. Or you could have said right here to here 34 and 34 if you so please. Right? So this one has it already done between each of them. But if it goes from like the -2 to the 1, you would have to say 68 plus 13.5. Do you know what I'm saying? You'd have to put it together. Okay. So here's where I want to get to, right here. I'm actually going to have to do this on a separate sheet of paper to help you guys see the pic. Oh my goodness, so much work. Okay, everything just flew. It's okay, it's okay. All right, so marker. Yes. So this is our mean. So right here, it says the mean is 33. STDs are mean. Done. Okay. Then it says the standard deviation is 4. That's that sigma business. So what it's saying is I want to go, if I go to the right, that's adding 4. If I go to the left, that's subtracting 4, right? This way is positive or greater, and this way is less than. So if I did 33 plus 4, I know it's 37 kids, I know, but then I make silly mistakes. Okay, so I got 37, and if I added 4 again, I'd get 41, and if I subtract, I get 45. Now I'm just gonna subtract 4, And so when I go this way, it's going to be 29, 25, 21. Do you see how I set that up? So the first thing I do is I put my mean in the middle, and then I use my standard deviation. STTs are means in the middle, STD. So my standard deviation is going to go positive to the right, negative to the left, and then it says, find the probability that we select however many values that's at least 25, at least 25. That means, so if I asked my mom for at least $25, would I accept $10? Heck no, right? I could take 30, you can give me 50, but I want at least 25. That means that I want from here all the way over. Well, we just said that this is 50% of the data. That takes care of a lot of it. Gonna want to come back to those numbers real quick. So again, Miss Cooper is checking this. I think you should as well. We knew that was 50 on this side, and then I've got my 34 and then my 13.5. So I'm gonna add those together to find out what's the percentage of at least 25. So 13.5 plus 34 plus 50. So I'm at 97.5%. The chances that I'm going to get at least 25 is 97.5%. Okay, I'm just gonna check and see if there was anything else in this lesson. I don't think so. Let's check out this error here. So like this one, the mean 4.6, that would go in the middle, and then you would add 0.4 to the right and subtract 4 to the left. It says this has a mean of 25 and a standard deviation of 2, but do you see how this went from 25 to 26 to 27? Are they adding 2? No. So that's why that one's wrong. Then right here, you're just asking, is this normal? Or is it left skew or right skew? And then right here, they're gonna ask you, what is this shaded? It looks to me like it's this one and this one, right? So that 34 and the 13.5. Anyways, I hope this helps and that you understand this. If not, come on Zoom. Again, I'm on Zoom Monday, Wednesday, and Friday at 10 a.m. and 1 p.m. I will tell you the honest truth. I'm seeing about 2 to 3 people a day. So I don't mind sitting there waiting, but it'd be even better, even if you don't have questions, just come smile at me and say hi and ask a question anyways. Like, Miss Cooper, do you like earthquakes? No, I don't.